Alright, so I should be able to finish off the moon in relatively good time. Um, Only two more slides left to go. I'm going to be talking about interior properties and where did the moon come from, how did it form, all that good stuff. So, unlike Earth, we don't have a lot of seismometers left. We don't have a lot of them on the moon. But unlike other planets in other bodies in the solar system, we have something on the moon, which is pretty cool. Um, and so we're able to get a little bit of information. There's some slight earthquake activity going on and whatnot, so we can probe the moon a little bit. And so even though we don't have as much data as we do on Earth, we got a little bit of a pretty good picture going on. So most likely, based on what we know so far, the moon has some similar layers to the Earth, although those layers will be in different proportions, and most likely not really a liquidy sort of outer core like there is on Earth. Probably, since the moon is nice and tiny, probably has cooled down and started to solidify at this point, or if not completely solid, then it's getting there. Uh, I think some current data suggests that parts of the core might still be molten, but it's probably just kind of few and far between, kind of like little pockets here and there. It's hard to say, you know. Even with good seismograph data, nothing beats actually going and collecting data from the actual source. But it's a little hard because even the moon's pretty big and still probably pretty hot down there. So drilling is not going to be something that we do in the very near future at all. So, but not much of a magnetic field, if any, and so that is some more solid evidence for the fact that it's probably not liquidy here. But the moon also rotates pretty slow, so not going to have much of a dynamo effect anyway. So yeah, no need to memorize what's going on. Just kind of a good idea of it's got probably a more dense core, although the average density of the moon is less than the Earth. If you go back to here, it's about 2,200 kilograms per cubic meter less dense than the Earth. So there's probably not as much heavier metals that have sunk towards the center, and that that could that could be some good evidence for which one of the formation theories is the most likely. Speaking of which, let's talk about those. So there's currently four different formation theories about where the moon came from, although one of them is most widely accepted today, and the others are not as widely accepted anymore because of certain major flaws. One early theory is the sister theory, which basically says that the Earth and the Moon would have formed together early on in the solar system's formation. Arguably, the solar system started as just a big cloud of gas and dust. We'll talk more about this in the next semester at how stars formed. But arguably, the entire solar system would have started from a big clump of gas and dust, and gravity would have squeezed it down together, and most of it would have turned into the sun. It would have gone into the sun, but whatever was left over would have given us our planets and all the asteroids and all the other debris and comets and ice balls and things that we still see floating around the sun. And so in this theory, some of that initial material would have also formed the moon. The only thing is, one major flaw is that the moon differs in density and composition. Now, you might say, well, the other planets aren't of the same composition as the Earth, and good point. So it's not a perfect flaw either, right? But because they're so close together, the Earth and the Moon are orbiting each other, then one might expect that maybe they would, if they formed at the same time together, they would be made up of similar material from like a similar part or a similar location in the cloud. Who knows, right? It's an interesting dilemma. Becoming a, it's like I always liked using the analogy of a detective trying to figure out what happened at a crime scene. You know, if you don't have like video cameras to actually record the crime scene, then you got to use other ways to try to paint a picture of what happened in the past. And the less the less evidence you collect, the more unlikely the picture you paint is correct. The more flaws in your theory. And if you have enough flaws, then the jury might have a hard time making a verdict. So, as you can see, the jury is having a tough time making the verdict about where the moon formed, but we have some different ideas. Another idea is a capture theory, that the moon, kind of like the strongest theory currently for how Mars got its two moons, Phobos and Deimos, was that they were captured asteroids, and that's pretty plausible because they're tiny and they're shaped like asteroids, and they're orbiting kind of in strange ways, and so possibly those were captured. But the moon is pretty big, so a lot of perfect things would have to have happened for an object so big as the moon to be captured. It's kind of like trying if you catch a ball, if you try to catch a ball falling from a building. Maybe let's say someone drops a ball from 10 floors up. Not gonna be too hard to catch. But let's say someone drops a piano. No, actually, let's say someone drops like a big suitcase filled with cheese from the 10th floor. It's gonna be harder to catch that because it's heavier, right? You might give it a good shot, but you might kind of injure yourself in the process of trying to catch something that big and heavy. And so, and especially if it's traveling really fast. So the one major flaw in this theory is that the moon's pretty big, so you have to have some pretty special conditions for the moon to be caught. But you never know. That, stranger things have happened, right? A third theory that is not amongst the major theory is the daughter theory, and this is basically saying that early on the Earth would have been spinning so fast that, and when the Earth was young and probably most likely very hot and liquidy, lava-y, magma-y, etc., and spinning really fast, that part of the Earth could have been ejected out and formed the moon. The major flaw with that is, how could the Earth have spun so fast? It's not spinning that fast now. What slowed it down? Etc., etc. And so it's kind of hard coming up with the mechanics of how that should work. And currently the most popular theory is an impact theory. And this is basically that a large body would have impacted the Earth, and the debris that formed from the collision would have kind of coalesced into the moon. And there are definitely flaws with this, and there's multiple models. I'm going to show you a couple that I found online. But, again, none of these theories are perfect because we don't have a video image of of this formation happening billions of years ago. So we got to use what evidence we have, which is not a lot. Here's a couple of models of possible collision scenarios. This one's kind of interesting. This one uses a really fast spinning Earth that's stretched out like an egg in a direct collision. Bam, 20 kilometers per second. So we're going to rotate up from the top view now. You can see debris is kind of spread out, and some of this debris could have come together and formed the moon later on. And you can see how long after the impact, 5 hours, 6 hours, right? Interesting thing is, in this, what is shown of this current simulation, I don't really see a moon. So I don't know if the video I found on YouTube is only part of the actual full simulation. This is 24 hours later. But, the moon forming disk Yeah, I'm not quite sure. These are pretty complicated. Most likely pretty complicated models using um, lots of particles. And I found another one. Let's see. I think this looks pretty cool. I'm not sure where these were obtained, so I would take these with a grain of salt. But the point I want to make is that there are multiple collision models out there, and you just change one initial condition in a certain model, and the whole scenario can change. So that's part of what science is building a model using a crazy computer that can handle tons and tons of particles, and running the models and seeing if the effects you want happen. So in this case, you got a collision and you got some material. It's like a double collision. It comes back and hits itself, and you got some material floating around. Um, I don't know if you can see the 3D effect, but it looks like it's spinning perpendicular to the plane of the video. And also, I don't really see there's something that looks like moon-esque, but it also kind of looks like it goes back into the Earth. So, anyway, like I said, take these with a grain of salt. None of these are, you know, definitely what actually happened. They're just models trying to maybe come close to what might have happened. So, but yeah, that's pretty much it. Um, Again, there's a lot more that could be discussed about the moon, but I wanna move on. I could go into the whole Apollo mission. What's kind of cool is China just launched. What was it called? China just launched. Where am I going here? Um, China shoots for the moon. What was it called? Just launched a rover to the moon. Should get there sort of soon. And I think China is pretty ambitious, and they want to um, send some people to the moon pretty soon, which is cool. I hope if they do it, that they don't just do it for a few years and stop. I hope it becomes kind of a permanent thing. What was it? It was a cool name. Jade Rabbit. That's pretty neat. U2 meaning Jade Rabbit. But anyway, this one doesn't show a picture of the rover. It looked pretty cool, kind of sort of like one of the Mars rovers. And I hope they do some cool things with it. I was reading also that it's not really going to do collect a lot of new data that we haven't seen yet. I think they're going to be using sort of radar or sonar or something to probe under the surface, and that's kind of new. But it's a good start. Good start. More power to them. Anyway, so there could be some interesting things in the next few years happening on the moon. But let's go on to Jupiter next. So yeah, that's it for the Earth Moon videos, and we'll see you next time.